And welcome back to Engineering Economy. We are talking about Chapter 5. We continue our discussion on evaluating single project alternatives. And in our previous lecture, we learned the internal rate of return method and we solved several examples. Now we learned a modified version of this internal rate of return with a more realistic assumption, which we call the external rate of return. And also we will talk about the payback period methods to evaluate projects. So let's get started. So external rate of return, again, rate of return, when you see this, it means that it's interest rate. And this external rate of return, we will denote it by ERR, external rate of return. There is one assumption that we make in internal rate of return, that we do this assumption implicitly, but it affects the procedure, the outcome of the procedure. What is that? In IRR, we assume that when there is a revenue from the project, a revenue means a cash inflow, right? Let me sketch a quick, I don't have too much place, but let me sketch a quick cash flow here. Assume that this is our project, we have some initial investment, and now we earn some money here. Let's say $1,000 from this project at the end of year one. So this $1,000, what is it? It is a cash inflow. It is in our pocket. This investment, we assume that it is inside the project. That amount is inside the project. But this 1,000 now is outside the project. It is in our pocket. And while we are calculating the rate of return, we are transferring all earnings and etc. to the present time using this IRR, using the internal rate of return. And it assumes that when you do this, we are assuming that we can reinvest this $1,000 in a project, in the same project or in a different project. We can reinvest it using the same rate of return. But actually, as a company, as a person, our rate of return that we can earn in a project is MAR, M-A-R-R. When we have a cash flow, we can use it in a project, we can use it in an investment to earn this MARR. Only in this project, we earn the IRR amount, only in this one. Of course, if there is another investment alternative that earns with the same amount with this IRR, it means that as a company, MAR of our project is equal to this IRR. But the thing is, whenever we have some money in our cash flow, the investment alternative that we can use for this amount is MAR. Okay, not IRR. But IRR assumes that, no, you can invest that money with the same interest rate. And this may not be realistic. This may not be valid in many cases. In most cases, for example, in order to decide on an investment alternative, we select if that investment, for that investment IRR is greater than MAR. Then whenever you have this cash flow, this earning, this return from the project, what you are going to do with that money? IRR assumes that you are reinvesting that money in the same project with the same IRR, but it is not possible most of the times. What you can do with this money is you can reinvest that money with MAR, not IRR. So it means that we need to modify this rate of return, internal rate of return, and we replace IRR with external rate of return. The idea is the same. Still, we try to find the interest rate that will equate the revenues to the expenses. What is the interest rate that will make the revenues equal to expenses? But the thing is, in external rate of return, we denote it by this epsilon. Okay, we convert all cash inflow and all cash outflow to present and future times using an external investment rate. Okay, this external reinvestment rate is usually MAR. Sorry, ERR is not denoted by epsilon. This epsilon is the external investment rate. Okay. So using this external investment rate, we move the inflows, the earnings and expenses to present and future times. And then we calculate the rate of return using this external rate and the present and future words of the expenses. In a minute, I will give you the procedure, the details of the procedure, and it will be more clear. Of course, if the MAR is equal to IRR of the project, then it doesn't matter if you are using external rate of return or internal rate of return, both will provide exactly the same solution. But if MAR is different than IRR, usually it is less than IRR, then they may give you different results. They may provide you different results. Therefore, it may be important to use this ERR as a more realistic version of the internal rate of return. Okay, how do we do these calculations? It's a simple procedure which consists of 3 steps. We move all net cash outflows to the present time using this external rate of return, okay, which we know. So we find the present value of cash outflows. What does it mean? It's the expenses at time 0. In second step, we find the future worth of all cash inflows, again with this external rate, which is MAR usually. So cash outflows, present worth, cash inflows, future worth, and then we make these inflows equal to outflows. Of course, one is in present time, the other is in future time. So it means that we need to find the present worth of these future values. But this time, when we find this present worth, we are using the ERR. We want to find that value. Okay, so after this, when you find this interest rate that makes this future equivalent of the inflows equal to present equivalent of the outflows, the interest rate that makes this equivalence is called the ERR. And if this ERR is greater than or equal to your MAR, then we accept it. Otherwise, we reject the project. In more detail, the procedure is this. We have expenses at each period K. We find its present worth for each period. And while finding its present worth, we are using this external rate, which is MAR. We know it. Okay. Then we convert this. We can do it in 2 ways actually. In the first one, we convert this present worth. We find its future equivalent at time N with this unknown interest rate. This I% is not known. And what is that future equivalent? That future equivalent is this. We have revenues at time K, and for each revenue we find their future value using this external rate. Again, this external rate is usually MAR. So we are finding its future value at time N. Okay, and then we satisfy this equation. I told you that there may be 2 methods. The first method, we move the present worth of these expenses to future time, or in the same way, we can move the future worth of these revenues to present time, and you will obtain exactly the same solution. The idea is this. In this graph, you can see the idea. We have different cash flows at different times of this project. We find the present worth of all expenses at time 0 using this epsilon as the interest rate. And we find the future worth of all revenues at time n, again using this epsilon. And then we try to find the interest rate that will make this future equivalent equal to the present equivalent. Okay, this is the idea in terms of graph. And simply this ERR, external rate of return, has two advantages over IRR. What is that? Remember, in the internal rate of return, while finding this I%, we tried this trial and error method and etc. But here, since we are trying to make a present value equal to future value, finding this interest rate will be easy. You can just solve it directly because we will use the formula f equals to p times 1 plus I to the power n. If you don't know this I, you can just use the logarithm and etc. Find it directly. It's easy. Okay? And also, in IRR method, sometimes when you try to solve the equation for internal rate of return, there may be more than one interest rate that satisfies the equation. So let me show with this graph. In the simple example, we said that the present worth changed like this with respect to the interest rate. It can be something like this. But actually, in some cases, depending on the cash flow, the present worth can move like this. So this value makes present worth equal to 0, and also this value makes it equal to 0. So which one is the IRR? This one or this one? So it becomes a problem in that case. Okay? So, but here, if you use external rate of return, you will not have such multiple rates of return. You will have only just single rate of return. Let's solve this same example that we already solved with the IRR method. Let's solve it using the external rate of return to understand it better. Again, what is the example? It says that we have an initial investment at time 0, which is $25,000. And the useful lifetime is 5 years. At the end of at each year, we have an increased productivity which accounts for $8,000. And at the end of 5th year, the market value of the new equipment is $5,000. The external rate is given as the MAR, which is 20%. So what is the external rate of return of this project? How do we find? Remember the 3-step procedure. The first step is to collect every expense at present time using this external rate of return, but there is just one expense in this project, and which is already at time 0. So there's nothing to do in this step 1. So what do we say? This expense at present time, and when we multiply it with this future, when we convert it to future time using this I prime, which is the external rate of return for 5 years, I want this to be equal to the future worth of all revenues. So I need to convert everything to future time. So this 8,000, it will be F given A. Now what interest rate I'm going to use? I'm going to use the external rate of return, which is 20% and 5. And also this 5,000 is already at time 5. It is already at time at the future time, so I don't need to convert that thing. Now I need to solve this equation. to find this interest rate, and that is the external rate of return of this project. So we can solve it. This 25,000 F given P I percent 5 is equal to 8,000 F given A 20% and 5,000. This is the equation that we have written. And actually from here we find this factor to be equal to this much. And if you use this formula, from here we find that this rate of return, external rate of return for this project is 20.88%. And since it is greater than MAR, which is 20%, this project is acceptable. But of course, there's a slight, it is slightly larger than 20%. So we accept this project, but barely. But if you remember, we solved this same example using the IRR method. And in that method, we found the rate of return to be 21.57%. This was the IRR. But when you look at the external rate of return, we see that it is even less than this one. Okay, the external rate of return is less. So if you make a decision depending on IRR, you say that, okay, it is greater than 20%. It is 1.57% larger. So it is a very good project. But actually, according to ERR, we see that it is only 0.88% better than the MARR. Okay, so this is how external rate of return is defined and used. This is another example for external rate of return. So it says that the external interest rate is 15% and MAR is 20%. Look, now the external interest rate is given different than MAR. Sometimes it can be. So what does it mean? It means that when you have an earning from this project, you cannot reinvest it with the percentage of MAR, but it means that you need to invest it in another alternative with 15%. Rarely these kind of situations occur, but it's rare. Usually MAR is the external rate of return. And the project cash flow is like this. This is the initial investment amount. These are all the expenses at each years for 6 years, and these are the revenues. Now we want to find the ERR of this project. Remember, the first thing is to calculate the present worth of the expenses. This 10,000 is already at present time. So this 5,000, I need to convert it to present time. 5,000. Now it will be P given F, and the interest rate is 15%. Look, I'm not using MAR, I'm using external interest rate, and it is 1 for 1 period. Now look at the others. So these are expenses, but at the same time we have revenues. So we don't convert these expenses to present time and these revenues to future time and find the interest rate according to that. Because what happens, this 1,000 expense is satisfied from this 6,000 of revenue. Okay, so it means that we need to look at only to the net amount, and the net amount here is 5,000. Net amount here is 5,000. So it is uniform 5,000. So it means that this part is only the present worth of the expenses. And if I multiply this whole amount by F given P, I% and 6, it will be the future value. And I will make this future value equal to the future value of the revenues, which is the net revenue each period, F given A, again the external interest rate 15%, and the number of periods is 6. Now from this one, the only unknown is this interest rate I prime, And if you just use it 1 plus I prime to the power 6 as a formula here, you will be able to solve this interest rate. And when you solve this interest rate, we find the rate of return to be 14.2%. Now, of course, after finding this, we need to make a decision. The decision part is also important. And the decision simply, should we accept the project or not? And in order to do this, I need to compare this rate of return with MAR, and I see that this is less than MAR, which is 20%. Since it is less than MAR, I reject. The project is unacceptable. Okay, so this is the external rate of return. And how do we compare or evaluate a single project using this method? Now we are going to learn a different method. This has a different perspective, a different viewpoint, and we are going to evaluate again a single project. Again, we want to identify whether to accept the project or not, but this time we will not look at the amount that we are earning, but we will look at when we are recovering our investments, the time of recovering. So this method is called the payback or payout period method. This is a very simple method, and actually we will talk about two versions of the payback method. The first one is the simple payback or payout method, and the second one will be the discounted payback period method. Okay, we will start with the simple one. This payback period looks at the liquidity of the project. What is liquidity? Liquidity simply is when you are earning your money back. As I told you, usually in investments at time 0, we have a lump sum amount, an investment amount, and after that we start earning money. And okay, we have this initial investment, let's say $100,000. So at what time we will be earning this back? We will be earning this 100,000 back. So it is the smallest number of years needed for cash inflows to equal to cash outflows. It is sometimes called the break-even life. We want these cash inflows to be equal to cash outflows, but here in simple payback period, the time value of money is ignored. Okay, this is a very simple procedure. You don't consider the time value of money. You just add up these values. So what is it? This initial investment, since it's an investment, it is an amount of money that we are paying cash outflow, it's negative. And at each period, we are earning some revenue and we are paying some investment. So this is the net earning. And we want to find the minimum period when these revenues, total revenues, exceeds the initial investment. It can be a fraction of the year. I mean, it doesn't need to be an integer value. It can be, for example, year 3.4. But what do? If it is 3.4, we round to the next highest year. So we assume that in 4 years we recovered the money back. Examples will be helpful in understanding. Okay, so look at this amount, this cash flow diagram as we solved in the previous case for the external rate of return. Let's evaluate the same project using the payback period method, simple payback. So what I am trying to do is I am trying to find when my revenues will be equal to my expenses. And again for this, for each one of these periods, I am going to use the net one. Okay, so 5,000, 5,000. We can modify the cash flow so that we have 5,000 earnings starting from year 2. Okay, my initial investment is 10,000 at year 0. But at the end of year 1, I have another expense which is 5,000. So this is what happens at the end of year 1. It is minus 15,000. What happens in year 2? So I have an earning of 5,000. So it is minus 15 total expense plus 5,000 earning, which is minus 10,000. Look, I'm ignoring the time value of money. I'm just adding them up. At the end of year 3, I have this as investment plus 5,000 earning. So it will be minus 5,000. At the end of year 4, minus 5,000 plus 5,000, it will be 0. Look, I'm having these values at the end of years and plus the earning, and this is 0. So what happened? It means that at the end of year 4, I earned a total value, total revenue, which is equivalent to my investment and expenses. And this is the payback period. Payback period. What is it? It is 4 years. In 4 years, we are starting to earn money. And what is the decision? How can we decide whether to accept a project or reject? Of course, we want payback period to be as small as possible. As small as possible. Why is that so? Because we want to earn the money back as soon as possible. If it is the case, then we say that this project's liquidity is high. It is more liquid and it's a good project alternative. If we are earning the money back at a very later time, we may decide not to invest. And in some cases, we are giving this criteria and said that if the payback period is more than 5 years, the project will not be accepted. If it is given in the question, then you will find the payback period. If it is less than 5 years, you accept it. Otherwise, you reject it. Also, in order to evaluate a project, we can look different aspects. You can look the present worth of the project. You can look the rate of return of the project. And you can look the payback period of the project at the same time. And if all of them are good, then you accept the project. Otherwise, you reject the project. The previous version for the payback period that we have seen is called the simple payback period. And in simple payback period, we ignored the time value of money. Of course, we can extend this method by considering the time value of money. And in this case, the method will be called as the discounted payback period. Okay? Discounted payback period when we consider the time value of money. And the idea is exactly the same. We are trying to find the time where my revenues exceeds my expenses. But while considering the timing of this, I am discounting all my revenues to the present time using the interest rate, which is MAR. Okay? So in year K, for example, if I have a net revenue of this much, I find it is present time and I subtract the initial investment from this cumulative amount, and as soon as this amount is greater than 0, then the month, the period of this is called the payback period. This is the discounted payback period. Okay, let's consider the same example and understand the difference of this example from the simple payback period. Assume that for this example, the MARR is 20%. Okay, again, I am going to consider the net in revenue at each period. So what do? I find the present worth of all investments. So this 10,000 is already in present time. I need to calculate the present worth of this expense as well. So it will be 10,000. Of course, it is negative. Plus, so I'm going to write here year 1. 5,000. Okay, of course, this is also an expense and it will be negative. 5,000 times P given F, 20% MAR and 1. This is what we have in year 1. What about in year 2? Let me say this value is A, equal to A. In year 2, what do? On this A, I'm adding this 5,000, but it's present worth. So 5,000 times P given F, 20% and 2. Okay, let's assume that this is B now. In year 3, on this B, I'm adding this third one, but the present worth of this P given F, 20% and 3. And we continue in this way and we check if this is greater than 0 or not. If this is greater than 0, whenever it is greater than or equal to 0, if we say yes, then this year is the discounted payback period. Okay, so in the previous case, in the simple payback period, we did not use these discounting. But in the discounted method, we use it. Therefore, it is more realistic. But the thing is, the simple payback period is a very simple method, and it will give you an idea quickly and easily. Of course, there are several problems associated with the payback period method. So let's talk about these payback period methods problems. It doesn't reflect any cash flows occurring after the payback period. So we just find the time that that the revenues exceed the expenses, the initial investment. What happens after this? Maybe there are no revenues at all. Maybe you just stop here. Nothing to earn after this. But the payback period doesn't tell it to you. Maybe you are not making more than $100. Okay? It doesn't indicate anything about project desirability. So it doesn't say that, okay, you are earning 20%, you are earning $10,000. It just says that you are recovering your initial investment in 2 years, in 3 years, something like this. Okay, so it just gives you the speed of recovering your initial investments. So, as a recommendation, it is advised to use this payback period only as a supplemental information and use it in conjunction with one or more of the other methods like present worth, future worth, annual worth, internal rate of return, external. Okay, use one of those methods plus this payback period so that you will have idea. You can say that, okay, we are earning in this project, we are earning 20% in 2 years and we are recovering the money in 2 years. Sometimes you can say that, okay, we are earning from this project 20% at the end, but the payback period is 10 years. But there's another alternative. You are again earning 20%, but the payback is 2 years. When you compare these two, you would say that the second one is better than the first one because you are earning the same rate of return and you are starting to earn it earlier, even earlier. Okay, so this is the idea of the payback period and the problems related to the payback period. Now let's consider another example. So this example, let me sketch the cash flow diagram, the one that we solved. Okay, so initially we invest 25,000 and then we start earning for 5 years 8,000, and also there's a market value at the end which is 5,000. So for this one, let's calculate the simple payback period and the discounted payback periods at the same time. Okay, so here this column represents the cumulative present worth for I equals to 0%. When I equals to 0%, it means that this is the simple payback. Simple payback, ignoring the time value of money. And look, we have initially 25,000 at year 1. Then we have 8,000 revenue. So minus 25,000 plus 8,000, it makes minus 17. Minus 17 plus 8,000, minus 19, minus 9,000. Plus 8,000, minus 1, plus 8,000, plus 7. So as you can see, the cumulative value switched the sign from negative to positive here. So it means that the payback period is in between 3 and 4. In between these 2 years, it switched to positive. And we said that we are taking the next rounded value, which is 4. So 4 is the simple payback period. Now let's consider the discounted payback period. In order to find the discounted payback period, again, this is our cash flow. Okay, this part is our cash flow. And for that cash flow, at the beginning of the year, I have 25,000. Then this 8,000 here, I need to find its present worth, and I'm using 20% MAR to do this. And when I find its present worth, I found this value. Okay? So in year 1, the amount in year 1, yeah, this one. So when I add to this minus 25,000, if I add this value, then the cumulative amount will be this much. Then I'm going to find the present worth of this second 8,000, which is this much. And if I add this to here, the value will be this much. Then the third one, find the present worth, which is this one, add it to the total balance, and you will obtain this. And continue in this way, and you see the sign is switched here. It is between 4 and 5, and we will take the next integer year, which is 5. And as you can see, the simple payback period gives you 4 years, but the discounted payback period gives you 5 years. So they may give you different years. And actually, if you think this one is more realistic than the simple payback period, but on the other hand, the difference is not too much. I mean, it will not be the case most probably that the simple payback period gives you, for example, year 2, but the discounted payback will give you year 7 or 8. Usually, there will be only 1 year difference between them, or maybe they will be exactly the same year. And this shows the graph of the cumulative present worth for the simple payback and the discounted payback. So how to read this graph? This minus 25,000 is the initial investment. And at each year, we are earning 8,000 and also an additional 5,000 here. So what happens in simple payback? It is just minus 25,000 plus 8,000, it is minus 17,000. This dashed one shows the simple payback. Then at year 2, I am adding another 8,000, so it is minus 9,000. Another 10,000, so it is minus 1,000. Another 10,000, so it is plus 7,000. So in between these years 3 and 4, we passed or we recovered the original amount. And in the last year, as you can see, it increases more steep because we are adding 8,000 plus 5,000 in the last year. Okay, so this dashed one is the simple payback period. The second one is the discounted one, and as you can see, it is non-linear. It is like a curve, something like this. And the reason is because of the discounting procedure. And similarly, or as we did in the previous table, now in year one we are not adding 8,000, but we are adding the discounted value of 8,000. Again, in year two we are adding the discounted, and etc. And as you can see, between year 4 and 5 we can recover the whole amount using this discounted payback period. So this is the end of this lecture and also the end of this chapter. And simply in this chapter we have learned different measures, different methods to evaluate a single project. We have learned present worth, future worth, annual worth methods, and in all of them we were using MARR as the rate of return, as the interest rate, and we calculated the present worth or annual and future worths. And the decision rule says that if these worths are greater than or equal to 0, we accept the project, otherwise we reject it. We also learned internal rate of return and external rate of returns, in which we were solving for the unknown interest rate, and our decision says that if the interest rate that you calculated is greater than or equal to MAR, you accept the project, otherwise you reject the project. And also we learned simple and discounted payback periods. And in discounted and simple payback periods, we simply find the time of recovering the initial investment. Actually, there is no decision rule associated with this. In some cases, we may be given that the company wants to recover the original amount in 3 years. In that case, we say that, okay, if the payback period is less than or equal to 3 years, accept the project, otherwise reject. And also, as we suggested, don't use payback period methods alone, use them with one of these procedures. So this is the end of this chapter, and in the next one we are going to learn how to compare more than one project alternatives with each other and select the best one.